All right, here's our bell work. And start out, they want us to identify the place value of each of these numbers. So we'll start with the 8. There it is, I found it. And so in even identifying the place values for these, we need to know where the decimal is. And there it is, okay, right between the 4 and 3. Because this is where the place values start, whether you're going from left to right or to the right. So the 4 is in the ones, the 5 is in the tens, 6 in the hundreds, 7 in the thousands, so the 8 there would be considered the 10,000s. And remember, this is not thousandths, it's just regular thousands on that one. And then where's the 1? So there's 1 there. There it is. Okay, now that's a decimal place value, so I'm going to go to the right, which means we're looking at THS type values, right? The 3 is in the tenths, 2 in the hundredths, and then the 1 there is in the thousandths. So don't forget the THS at the end of that. It is thousand, but thousandths. There we go. So yeah, there was a little bit of mix-up on the last homework because they just underlined these values and said, what is the place value there? They didn't want you rounding with that underlining, just wanted you to write out what the place value was of that number. And even then, like this, we know that's 8 10,000ths, but we don't want you to show the 8 there. It's just write out 10,000ths. That was all. Now, this is a key component in pretty much all of mathematics. If you can understand that you can write things differently without changing a value, then you're well on your way to doing pretty much any kind of math, even all the way up into the calculus-based stuff, okay? For example, in the past we've seen this where it's like, you know what, I don't want 10, I'd rather see 6 plus 4 for some reason, okay? Now, there's always a reason for that, but now we're going to be doing the same thing with fractions, and we'll go over some of those examples. Again, there's no difference between these two. It's just the way that they're shown. That's the only difference, but the value is not changed. So, yeah, fractions, and again, this is the important part. They can have the same look, or they can look different, but they will have exactly the same value, okay? So what this means is you can either take control of the fractions or, and this is kind of unfortunate, but it does happen from time to time, they can take control of you, okay? Now, what does this mean? It means that I've seen people that, they start working with fractions and suddenly it kind of destroys their life. I mean, not the same way like losing your job would, but I've seen it ruin lives before, okay? So take control of the numbers. If they start to take control of you, then usually it's destructive. So this comes down to writing fractions differently, right? But while preserving the same value, it's like saying, hey, look, here we got, let's say this is a sandwich, and you got some lettuce in there, and I'll call that bacon, and you can't see the mayo because it's white. But there's a sandwich, okay? And let's see, if I cut this sandwich in half, and I said, look, you get this one piece out of 2, you'd be like, hey, that's pretty good. I like having one piece out of 2. Now, if I cut this further, and let's say these were all equal parts, now I'll give you these 2 pieces, right? So you get the 2 pieces out of what was 4 pieces. The question is, did you get anything different? Well, no, you didn't. You could either have 1 piece out of 2 or 2 pieces out of 4. All that changed was the sizes of the pieces, right? So that's important to know, and we'll talk about how that works. But 1 piece out of 2 or 2 pieces out of 4, it's the same exact value. It's just shown different, okay? And there are reasons mathematically which we would want to show these different. So if you can understand that, then you can go pretty far, not only with fractions, but with other stuff, okay? So fractions. As it turns out, fractions are division. And so a lot of students forget this. Now, when we saw division before, we said dividend divided by divisor equals quotient. Okay? And remember, the dividend tells you how much you're splitting up. The divisor tells you how many groups you're splitting it up into, and then the quotient will tell you how much each group gets. Okay, so to demonstrate this, I'll use the 12 and 2 right there. So if you had $12, let's say, and you're going to split it up between 2 people, then the quotient will tell you how much each person gets, and that would be division, right? Because you're going to split it up equally. Well, each person here would get $6, okay? Now, that's a straight division problem, and we can see that these are all shown as division, and division can be shown differently, but it's still division, right? Like this is an actual division sign. This one is an actual division sign. It's just shown differently, okay? Or even long division right here, which has the dividend inside and the divisor outside. Remember, that's kind of backwards. But this fraction is also division. So I've even seen some students, they like to actually show the two dots right there to indicate that it is actually division, okay? And so if that helps you, then do it, as long as you do know that that's division. But notice that in the top would be the dividend, and in the bottom is the divisor. We actually have formal vocabulary for that, okay? Now you should ask, well, why are math people changing the vocabulary? Couldn't we just keep it a dividend and divisor? Yes, we could, but then we wouldn't look as smart as people think math people are, okay? So as we change the vocabulary, but without changing the definition, then it also confuses people, which makes us look even smarter. So if you need some strategies to look smart, there you go, okay? So the new vocabulary for fractions, the top number is called the numerator. The bottom number is called the denominator, but the answer to this division problem is still a quotient, okay? So I'm not going to be using dividend and divisor so much unless we see straight division, even though it's important for you guys to understand that when we see fractions, I'm going to be using this vocabulary more, numerators and denominators, okay? So if I were to write $12 divided by 2 people is $6 right there, again, your numerator would be the $12 because that's how much money you're splitting up. The 2 people is the denominator, and then the quotient there again is $6, okay? $6 per person. Now formally, fractions should not have decimals in them. In fact, they shouldn't have fractions in them either. So not that we should see decimals in them, but I think eventually you might, in which case you should change those always into more proper type fractions. All right, so there's our new vocabulary. Remember, numerator over denominator is the quotient. Now, if values are written as fractions, it kind of communicates something differently, right? Like with the division problem, we say that the dividend tells you how much is going to be divided. The divisor tells you how many groups it's divided into, okay? With fractions, we're usually comparing something that would be considered whole. I like brownies, but I think we're going to see more like pizza type stuff today. So the denominator tells you how big the sizes of the pieces are, kind of like the sandwich example. And then the numerator tells you how many pieces or parts there are either left or the examples we're going to see here for shading. That may not make a lot of sense, but let's just make sure that we have the numerator and denominator thing down here, okay? Remember, the top number is the numerator, and then the bottom number is the denominator. So I'm gonna just say, hey, look at the 2/3 there. The top number has to be the numerator, which means that the bottom number has to be the denominator, just like this, okay? Well, what about for 1/4? Well, the top number is the numerator, the bottom number is the denominator, like this, okay? Now this is important because I'm going to be using this vocabulary quite often. Numerator, denominator, numerator, denominator. It's important when I say denominator, you know that we're talking about the bottom number of the fraction. Okay, so if I say, look at that denominator 4, you're like, why did he say denominator? It's kind of a redundant thing right there, okay? It's the bottom number in a fraction. All right, and same with numerator. You need to know what that means if I ever use it, because I will be using it quite often. So let's write a fraction for this one, and there's a few different ways to do that. Although I think we'll see some of those examples later. Okay, so it just wants to know what fraction of the circle is shaded blue. So I'm going to start my fraction line like this. Okay, so I'm going to put a numerator here and a denominator there. If I look first for I'm going to start with the numerator. How many pieces are actually shaded blue? There's 1, 2, 3, 4 pieces shaded blue. So that means my numerator is 4. 4 pieces are shaded blue. And then the denominator tells us how many pieces would make one full, I guess I'm going to call this a pizza because I do like pizza. But that'd be 5, 6, 7, and 8 pieces total. So that'd be 4 pieces are shaded blue out of 8 total pieces on this pizza. That would be considered the fraction. Now again, like I said, there's at least 2 other ways to write this. at least with this diagram. And we're going to see that in a later example. But for now, it's important for you to understand the difference between your numerators and denominators and what they represent if you were even to show a picture of this, even though pretty much in future lessons we won't be seeing a lot of pictures. Now that brings us to mixed numbers. Okay, so we just saw a type of fraction there in the last example. But mixed numbers, okay, what you see here is first the A value there is a whole number. I guess we call it the whole number. It's not a hashtag, that's a whole number symbol. And then the B there, this is still a fraction, by the way, and the B would be considered the numerator. And then the C there is the bottom number, so it's the denominator. Now, while we may not see this right now, it is important to understand that this fraction, later on, we're going to call that a proper fraction. It needs to be proper, and it needs to be simplified. We'll go over what both of those mean here later on, okay? But a mixed number is just a whole number and then a fraction. They combine to give us a total value of whatever it is that we're looking for, okay? Be careful when you write your mixed numbers, because the whole number needs to be deliberately bigger than the numbers in your fraction, okay? Because if you don't write them bigger, then you may end up with something like this, 5 1/8 like this. That looks like 51/8 if you ask me. Like I know the 5 is kind of offset there, but what you want to do is you want to make the 5, the whole number there, bigger than both the numerator and denominator of the fraction, okay? So this example just wants us to write this example as a mixed number. So I'm looking for whole pieces, right? That would be the whole number in the mixed number. So I got this one full pizza, another full pizza, another full pizza. That's 3 full pizzas. So I'm going to set this up with some boxes, okay? And I'll just fill in the boxes for my mixed number. So I got this big box, that's going to be the whole number, and then I'm going to have a numerator, and then I'm going to have a denominator, okay? So there's my fraction line. So that's why we see here that the whole number is bigger, okay? Now I just counted 3 full pizzas right there, so that's going to be my whole number there, 3. And yes, it is possible for that to be negative, but now we're not worried about that, okay? Now we do have this last pizza here, right there, right? And so I would look and see how many pieces are shaded. That's my numerator. I see 1 shaded piece, so I put a 1 in my numerator. How many pieces are there, though? There's 1, 2, 3, 4, 5, 6. I went clockwise. Some people say counterclockwise. In any case, there's still 6 pieces. That tells you that's the sizes of each piece. It's a sixth of the pizza. So that's our denominator, sixths, right there, okay? So 3 1/6 would be considered the mixed number for this particular scenario. And we'll look at a different way to write this exact same scenario here in just a minute, okay? So I did mention proper and improper fraction. Well, not improper, but proper, at least before. The difference between these two is that proper fractions have a larger denominator than a numerator, okay? So a very common fraction that we've seen already is 1/2. This is a proper fraction because the bottom number is bigger than the top. Another common one would be something like 3/4. That's a common one. Maybe something not so common, I don't know, 7/11, like that. And it wouldn't even matter if it's negative. As long as the bottom number is bigger, the denominator is bigger, then it's considered a proper fraction. Well, the improper fraction stuff just reverses that, okay? So it just means that the top number has to be bigger, such as 5, let's say 5/3. See how the top number is bigger? Or you could even say something a little bit more common like 3/2. It could even look something like this, 6/1, okay? Again, that's just important that the numerator is bigger. And again, these could be negatives, negative 13/9, okay? So again, we don't really care about the negative. It's that the top number is bigger than the bottom number. That's the important improper fractions, okay? So when I say proper fraction, again, that's kind of just a visual check. You're just checking the bottom number to be bigger than the top. If I say it's an improper fraction, you should know right away that the numerator or the top number is going to be the bigger of the two. Now, along these lines, only improper fractions can be written as they can also be written as mixed numbers. Okay, and proper fractions, they could. It's just the whole number is a zero, because there's not enough in the numerator to make a full piece for proper fractions. Okay, but you can see down here with the improper fractions, there's more pieces than the sizes of the pieces, which means you can make a whole out of that. We'll talk about how to do that here in a second. So here's this example. We just saw that you could write this as 3 1/6, right? Now I'm going to write it as an improper fraction, because only mixed numbers can only be written as improper fractions, not proper fractions. But I'm going to write this mixed number as an improper fraction. It's going to look different, but it will not have a changed value, okay? So on this example, you'll see that each of the pizzas has been split into 6 pieces. That means that the sizes of the pieces, that should be the denominator, is in sixths. Just like we saw over here with the 3 1/6, okay? Well, then how many pieces are there? Well, if I look at each pizza, I see that there's 6 pieces to fill this pizza. There's another 6 pieces in this pizza. There's another 6 pieces in this pizza, and then only 1 piece in this last pizza. So I'm going to add these together, and what I get, that will be my numerator. That tells me how many of the pieces there are to fill in this top value for my improper fraction. So 6 plus 6 plus 6 is 18, plus 1, that's 19 pieces, and they are 6th size pieces, so we end up with 19 sixths. This has the same value, this 19 sixths has the same value as the 3 1/6. It's just shown in a different way, all right? Now, along those lines too, if in real life, you would not usually use improper fractions to work. But in a pure mathematics setting like this one is, because it's a math class, the improper fractions work better, okay? So in the future, if you ever see a mixed number, it will be important to be able to change it into a improper fraction. Again, it won't change the value, but it will change the way that it looks. Another thing that you'll need to notice between mixed numbers and improper fractions is that the denominator didn't change, right? You got a 6 denominator, 6 denominator. That should be true whenever you're converting between the two if you need to. So how do we change improper fractions to mixed numbers? Well, you're going to divide, and so this will usually require some long division, because remember, the fraction line actually is division. It's just sometimes the numbers are kind of big, so we're going to have to use some long division on this, okay? Now the quotient, whatever you get for the quotient up here, that is the whole value of the mixed number. That would go here. And then you'll look, and then you'll find some kind of remainder sometimes. Whatever the remainder is, that would go as your numerator. And then once again, your divisor from your division problem, or your denominator, is just going to stay. So that will set up your mixed number, okay? So here we go, 37/8. This is a division problem. I will divide 37 divided by 8. Again, it's numerator divided by denominator. And I'd say, well, how many times does 8 go into 37? Well, I'd count 4, because 4 times 8 would be 32. So when I subtract this, this tells me how much of the 37 was used. 32 of them were used, which leaves me then with 5 pieces remaining on this. So that's my remainder. Now I do want to write this as a mixed number though, right? So my 37/8, there's my fraction line. I keep the denominator as 8. That's always a given. But I just found that the quotient was 4, so there's my 4. And I found the remainder of 5, that's my numerator, 4 5/8. These have exactly the same value, but they're just written in different ways, that's all. Okay. Now again, I'm showing this to you even though you may not use it in the future, just so we can understand how to go back and forth. Okay, because in order to change a mixed number to a improper fraction like we see here, hopefully you kind of see the strategy that we're going to be using. Or of course you could use the 3 pizzas and the 1/6, and maybe that gives you kind of a strategy too. So mixed numbers into improper fractions. This one's the most useful of the two in the math class. This is called cycle method. And you can see you're going to take the whole number and multiply it by c. Remember, it's kind of like those pizzas that we saw earlier, right? Where we had the pizzas and then it was split into, I don't know, 6 pieces like this. Okay, and then, what the heck, right? So we had 3 of these. So remember, from those 3 pieces, those 3 pizzas, right? Each of those was split into 6 pieces. So that's why you'd say 3 pizzas, 6 pieces each. 3 times 6, that was 18. So that's where this multiplication comes from. And then, of course, we had the 4th pizza, something like this. And then there was only the 1 piece that was shaded in, right? Well, that was the one from the 1/6 to add from the numerator right there, okay? So let me demonstrate that. We wrote that as 3 1/6. Cycle method would say 3 times 6. Again, that's the 3 pizzas. 3 times 6. I'll do it there at the bottom. 3 times 6 is 18. And then we had this last piece right here to add to it. And that would have been the one from the numerator. 18 plus 1 is 19. Remember, that was 19 is the same as 19/6. Okay? So let's practice some cycle method, changing this mixed number into an improper fraction. So here comes some cycle method. But before I do the cycle method, I'm going to write the denominator the same, because remember, the cycle method stuff is not going to change the denominator. It only changes the numerator. So to start out, I'd have 7 times 9 there, which is, and that's multiplication, 7 times 9, which is 63. So from these 7 whole pizzas, 9 pieces each pizza, 7 times 9, 63 pieces. Then we'd have to add the 5 numerator there, because that's what's left from that last pizza. And that would give us 3 plus 5 is 8. Drop the 6. That'd be 68 ninths. Okay, same exact value, just shown in a different way. That's it. All right, simplifying fractions into what we call lowest terms. Now, when we say lowest terms, that usually indicates that we're using some form of division on this. Okay. So a fraction can be written in different ways without changing the overall value. So just like we saw on this one, remember we counted this to be 4 pieces that are shaded blue out of 8 pieces, right? Is there a simplified way to do this? Yeah, it just means, and when we're looking at pizza like this, it means that I'm looking to combine pieces of pizza, right? So I could say, look, I'm going to split this up into fourths. Now I got 1 piece here, 2 pieces out of 4 pieces, right? So then we would say that's 2 out of 4. Now that is simplified. Is it fully simplified though? No, because we can go back into this thing and look, we just cut it off. We can cut it off right here. See, now I got 1 piece. That would be 1 piece out of 2 pieces, okay? So that ends up being, well, 1 over 2. And this 1 over 2 would be considered fully simplified, okay? Now that's using a diagram to do this, but we need to be able to do this without having to use diagrams, because they can be impractical sometimes, okay? So one of the methods we use is called scaling the fractions. Now with changing these into lowest terms, again, we're using division. And division would be considered what we call scaling down the fraction. Let's see if we can write this. Scaling down a fraction, okay? Now, when we say scale the fraction down, it means that whatever you do to the numerator, you got to do it to the denominator as well. Okay, so whether it's multiply or divide, you got to use the same operation, and you got to use the same number as well. Now, for scaling fractions, the only operations you can use is either multiplication or division. Multiplication will be used to scale these up. For scaling down, we're going to be using specifically division, okay? So yeah, we can find equal value fractions by multiplying or dividing. The numerator and denominator, it's got to be by the same number though, okay? So whatever you do to the numerator, you got to do it to the denominator. That will maintain the equality portion of the fraction, okay? If we want a fraction in lowest terms, we usually use division, which we will see, okay? Because division will take numbers and make them lower. So here's an example. We're going to write this in lowest terms. So the first thing I would do is look at 24 and 32. Is there something I can divide both these by and not get a decimal out of? Yep, there is. I could divide 24 by 2 and 32 by 2, okay? Now I know what 24 divided by 2 is. That'd be 12. If you don't know what 32 divided by 2 is, you may have to use some long division. That's okay if you do. Okay, so 2 goes into 3 once. 1 times 2 is 2. subtract, and then you got the, drop the 2 from the 1s. 12, 2 goes into 12 6 times. That'll give nothing remaining, so I got 12 over 16. Now, even though I did some simplification, I made a fraction that has the same value, but it's smaller numbers. Can this one be simplified? Because I should check. And yeah, these are both even numbers, so I know they're still divisible by 2. So 12 divided by 2 is 6. 16 divided by 2 is 8. Boom. Well, again, we should check. Can these be simplified? Yeah. 6 can be divided by 2 still, and 8 divided by 2 also. 6 divided by 2 is 3. 8 divided by 2 is 4. And now my final check. Can this be simplified? 3 is only divisible by 3 and 1, where 4 is not, so automatically this is not simplifiable. If one of the values was a 1, it's automatically simplified, by the way. Now, to look at this just a little bit differently, you could have scaled this one time and have been done if you have your multiplication tables memorized very well. For example, you may see that the 24 and 32 are both multiples of 8, which means they're both divisible by 8. And when you do this, 24 divided by 8 is 3, and 32 divided by 8 is 4. See how we get the same value on these two, whether it's this one or this method, you get the same answer, okay? So we've scaled those down in 2 different ways, but we get the same answer because, again, it's the same fraction just shown with different numbers in the fraction. Now, this may take some time to understand what you need to divide by. So be prepared to, you may even want your multiplication table out from, what was that, 1.4, I think. And you may want to refer to that often if you need to. All right, what about this one? 45 and 63. Now, some of you know how to tell if numbers are divisible by 3. But if we take this a little bit further, hopefully we can see that these two numbers are both multiples of 9. Which means that then I can divide 45 by 9 to get 5. And 63 divided by 9 to get 7. And then, of course, I would check to see if these are divisible by the same number. And the only one I can think of is 1. So keep in mind, 1 is a unique value. You could divide these by 1 as many times as you want to, but you're going to get the same values back. So this is considered fully simplified right there. There's a second method for simplifying fractions, and that is with prime factorization. Now, prime numbers, sometimes we forget about what they are. They're numbers that are only divisible by 1 and itself. Some common prime numbers are 2, 5, 7, 11, and 13. Okay? These are prime numbers. They're only divisible by 1 and itself. 1 is not prime because, well, it's neither prime, it's the identity. And so a simplified fraction or reduced fraction is where the numerator and denominator do not have any common factors to simplify with. We'll show what that means. But with prime factorization, you're looking for matches of factors. Remember, a factor is a multiplication problem. So we're looking to change the values into what they're multiplied by in the prime numbers. What prime numbers you'd multiply to get that specific number, okay? And then if there's matches in the numerator and denominator, we can cancel those away as phantom ones. So 48 over 144, okay? So I'm going to simplify this. And what I mean by that is I'm going to make this, I'm extending the fraction line because I'm going to change this, both 48 and 144, into its prime factors, okay? So I'm looking at what do I multiply by, what do I got to multiply in order to get first 48, okay? Now I use what we call a factor tree like this. You don't have to use a factor tree, you can just use a list if you'd like. But 48, I know, is the same as 4 times 12. And again, this is the importance of understanding and knowing the multiples, of at least the first 12 multiples of every number up to 12, okay? So 4 I know splits up further into 2 and 2. Now, if I see any primes like 2s, then I circle them. And that kind of ends that branch of the tree. And then 12 splits up into 2 and 6, we'll say. And then 6 splits up into 2 and 3. So see how I circled the 2s and the 3s. Now that ends that tree because at the end of each branch we have a circle, okay? So 48, my numerator, again, I'm not going to show it as 48, but I'm not going to change the value either. I'm going to write it differently. That's going to be 2 times 2 times 2 times 2 times 3. Okay, and that's okay if I do that. It has the same value as 48. I'm just showing it differently, that's all. And then I'm going to take my other number, the denominator, 144. Let's see if we can split this up. So I'm going to say 12 and 12. And then 12 would split up into 2 and 6, which we've seen. And then 6 splits up into 2 and 3. So that ends that part of the branch, that side of the branch. And then 12 will split up into 2 and 6 again, which we've already seen, split up into 2 and 3. So I'm going to list these from left to right. 2 times 2 times 3 times 2 times 2 times 3. Now that does equal 144. What I have written in purple there in the denominator is just shown in a different way, that's all. And if I find any matches in the numerators and denominators, those go away as phantom ones. So you've seen teachers perhaps cross these out like this. That's a 1. And in the future it will be a phantom one because I don't have to look at that phantom garbage, okay? It will lurk in the shadows, which kind of makes it creepy. But here's another set of 2s. There's another set, and yes, they don't have to be immediately stacked above and below each other like these ones. They can be kind of diagonal like that. Some students have been known to showing it like this. Those 2s phantom 1 each other. And then the 3s as well here, right there, okay? Now, whatever is left over will be whatever would be simplified in the fraction. So see the 3 in the denominator, this one? That's going to be my 3 in the denominator of the simplified fraction. The problem here is that there's nothing showing in the numerator. Well, remember these are phantom ones? I just want to show one of those phantom ones out there as just a green one right here. So this would be considered fully simplified. Now, if you go back, that means that 144 and 48 are both divisible by 48. You would have gotten 1/3 right there. Or you can divide by 2 and then divide by 2 and some other 2s and stuff. And you still would have gotten 1/3. So here we go. Let's do a 36 over 21. Again, I'll use prime factorization. Do remember, though, that it's never a requirement to use a specific method on these, okay? So if you don't want to use a specific method, then don't. Like if you hate prime factorization, hopefully you can do the other method, but you got to be able to do one. I'm not saying you have to like any of them, but whatever. So 36, let's start with 36. I'm going to split this up. That would be, in fact, I'll do red. I'll do 6 and 6. Some people would say 3 and 12, which works, whatever. And then 6 and 6, of course, 3 and 2, I'll say, and then this is 3 and 2 as well. That ends that tree. And then 21, oh, this one's not too bad. That's going to split up into 7 and 3. Okay, so my new fraction, shown with its prime factors, 36 is 3 times 2 times 3 times 2. And then 21 will show as 7 times 3. Now, is there any matches in the numerator and denominator? Sure there is. I see this 3s. Some of you may have phantom 1'd it with this 3, and that's fine too, because you're going to get the same value after multiplying. In the numerator, when I multiply, 3 times 2 is 6, times 2 is 12. So that's my new numerator. And in the denominator, we just got the 7 left over. So that's 12 sevenths, which is the improper fraction there, simplified from 36 over 21. Division by 1 is so great because whenever you divide by 1, you're going to get the same thing back. So if you ever see a fraction like this, where the 1 is the denominator, just write the numerator out, okay? Just like you see right here, 7 over 1, just get rid of that denominator, make it 7. Now this also means, and this is important to know going forward, if you ever saw a number, let's say 8, in the future, we're going to need to show this not just as 8, but as 8 over 1, you can. Okay, so not only does it go this way, but it also goes that way as well, okay? So now we're not going to be doing that on this, because between these two, the 8 would be considered fully simplified, okay? Like this one. Here's 13 over 1. To fully simplify this, just make it 13. That's it. Please do not overcomplicate that. Just all you're doing is writing out the numerator there. All right, fractions in base 10s. These are nice because any zeros on the tail end of a number can be phantom 1 with each other. Some people say canceling out. I don't like to use canceling because it is a phantom 1, okay? So for example, I could say, look at these zeros right here. They're gonna, let's see if I can do that better. There we go. Those become a phantom 1. Some people like to just use a separate marks like this, that's fine if you want to do that. But anything to the right, on the far right of the number, any zeros that match, yeah, we can phantom one those. So there's another one, there's another one. Well, what does this do? It changes this problem now into 8,400 divided by 2, instead of 84 million divided by 20,000. So we're not having to deal with such a big number at this point. Now, I don't have my two multiplication tables memorized to 8,400. Maybe you do. Either case, I'm just going to use some long division on this. So 8,400 divided by 2. 2 goes into 8 4 times. 4 times 2 is 8. Drop the 4. 2 goes into 4 2 times. 2 times 2 is 4. So that zeroes that out. Drop this 0. 2 goes into that 0 0 times. 2 goes into the second 0. Still 0 times. So to finish fully simplifying this, we would just write it out as 4,200. So that's the nice thing about with the zero thing is that, again, it made this division a little bit smaller. And that's a nice strategy until we can start using calculators anyways. All right, so writing fractions that are the same, they have the same value, but in a different way, right? That's one of the things that we need to be able to do. Just like we saw before, it is possible to write 1/2 as, I think we saw it as 2/4 and also as 4/8. Some of you may have said 3/6. Yep, that would work as well. There's lots of different ways to write 1/2, okay? But on this one, it wants us to write just any equivalent fraction for 7/8, okay? So, one of the most common values to use on this, there's my fraction. Now, I'm going to have to scale this one up. If you could scale it down, you could. But I'm going to scale this one up by multiplying. So 7, most students just multiply these by 2. Remember, whatever you do in the numerator, you got to do in the denominator there too, okay? So 7 times 2 would be 14. 8 times 2 is 16. And that works. That would be an equivalent fraction. Personally, if I see a problem like this, I take my 7/8. I simply multiply them both by 10, which really just allows me to tack on a 0 to both of them, right? So if I saw 7/8 like this, to change the way it looks without changing the value, just tack a 0 on, you're done. Okay, that's one way to do that. Of course, in the future, you'll have to force the denominator to be a specific value, and there's ways to do that, which we will show kind of as an intro with some of these other problems. And this one, it just wants any fraction equivalent to 5/6, any fraction. So again, a common value would be 5 times 2 and 6 times 2, which would then give you 10/12. Again, some students would say, well, can't we just multiply these by 3 as well? Yeah, you could. And then you'd get 15 30ths, okay? Now, to take this a little bit to an extreme here, some other values that would work, because, again, there's pretty much an infinite number of values that would make this equivalent. As a fraction, you could have used 20, what is that, 20 24ths? I put 30ths right there, sorry. I don't know where that came from. That should have been 18ths. 20 24ths, that would be multiplied by 4, multiplied by 5 is 25, that's 30ths. Or 6, 36. And again, this list would go on forever pretty much. But I'm just pointing out that if you need an equivalent fraction, you can find a lot of them. But again, in the future, it may be important just to have the one that has the denominator of 24, and you need to know how to be able to, you need to be able to get that specific fraction there. Like this one. Okay, enter a fraction that is equivalent to 1/9, but it has a denominator of 18. So let's write this out. What is this talking about? It's saying if you have this fraction 1/9, we need something that's equal to it, but has a specific denominator of 18. Okay. Now, my blank is over here on the right, which means that the way that I have this written, I would have to move from left to right, okay? What this means is that I'm looking at the 9, and I got to force it to be an 18. What would I have to do to 9 to make it 18? And when we're scaling with fractions, you cannot use addition and subtraction. You have to use multiplication or division. So would I multiply with 9 to get 18, or would I divide? The answer to that is multiplication, because you made it bigger. Well, what would I multiply 9 by to get 18? It's 2. 9 times 2 is 18. So I see I multiply the denominator by 2, so I'd have to multiply the numerator by 2 as well to get, well, 2. So the corresponding numerator with the denominator of 18 would be 2. This fraction has the exact same value as this fraction, just shown differently. Do keep in mind on the homework, it will just want you to write whatever the missing number is. In this case, you just put a 2 in the box. Okay. All right, same idea on this one. We want an equivalent fraction, but this one wants a specific denominator of 24, right? Now I know that since the unknown is on the right of the 3, I'm going from left to right, which means I'm going from 4 to 24. I'm going to make a 4 to 24. How? Well, I'm going to have to multiply by something. Okay, 4 multiplied by what? Well, again, hopefully we have our multiplication tables down, because that'd be 4 times 6 to get 24. And then you'd have to multiply the 3 by 6 in the numerator to get 18. And again, the only thing you need to write on the homework is just the 18. Here's this one, 7/5 equals blank over 135. We've got to fill in that blank to make this a true statement. You guys take a minute and try that out, okay? We're still working on this one. Do and finish up, and then compare what you get with what we end up with, okay? So I got 7/5 equals something over 135. So once again, we're kind of moving from left to right again, okay, because the blank is on the right side of the 7. So it's a matter of what would I multiply 5 by to get 135? Yeah, that's the bottom of the denominator. Now, I don't have my 5 multiplication tables memorized up to 135, so we're going to have to use some fact families on this, okay? So that means I'm going to take the product, 135, and I'm going to rewrite this as a division problem. Remember the fact families? With one of the factors, 135 divided by 5. So 135 is the dividend, and 5 is the divisor. And then this would be the blank on that, okay? So I can do that, no problem. 135, let's divide this by 5, okay? So 135 divided by, 5 won't go into 1, but 13, yes. 2 times 5 is 10. 3 minus 0 is 3. The 1 0 out. Drop the 5 to make it 30. 5 goes into 35 7 times. 7 times 5 is 35. Nothing remaining, which is kind of what we want to see. But that means that 135 divided by 5 is 27, which also means that 5 times 27 was 135, which means I'd have to take 7 and multiply it by 27 to get this new numerator. So I'll have to stack and multiply that. 27 times 7. 7 times 7 is 49, carry the 4. 7 times 2 is 14, but adding the 4 makes that 18, so we end up with a 189 numerator. So these two fractions, again, they're equal. They may not look the same, but they are definitely equal using this process that we just did. Well, this brings us back to the objective. We should now know how to write fractions and mixed numbers differently. So again, it's just, you need to be able to write them equivalently, but with different numbers. And also, I guess part of that, of course, would be simplifying the fractions. That's writing the fractions differently without changing the overall value. That's the important part. Yeah, this is kind of a long lesson, but the reason why it's so long is because we're going to be using fractions, of course, not only in this unit, but I think in the next 2 units quite often. And if you can't work with fractions, then the rest of the class kind of goes with pot, okay? So please, you have to be able to understand how to work with these fractions, at least at this degree, before we start operating with them, because that's what we're going to be doing in the future.